So today's video will just be a very quick video. Actually today this piston has kind of too much worn. So I take it out to replace it with a new piston and rod assembly. And actually very luckily, this assembly here has kind of a manufacturer defective. So that gives us the chance to take it apart and take a look about its construction. So let's start from the defective, which you could see here. This piston pin stretches out. Actually, it's not stretching out. It's actually it's moving freely in this direction. It can be pulled out from here. We will take a look at this rod later. Sorry, this pin. And the reason for it to move out in this direction is that I'm not sure if the camera can do it, but if I zoom in a bit, in this bore here, you could actually see kind of a punched mark. That's one of them. They use such a punch method to fix, that's another mark, to fix the rod inside and let the rod won't move outward. Kind of the similar function as a C-shaped clip on bigger engines. So in this bore here, it has those punched marks, but in the opposite bore here, actually I think they have it, but this is a bore which it won't came out, but this one here, you could actually see those marks, but those marks are actually not stretching out. It's only punched inside the piston body, so it will not help to fix the position of this piston pin anymore. And the pin actually moves out during the operation and make such kind of a scratch in the inner running surface of the cylinder, and the resulted aluminum kind of aluminum powder or a small material of aluminum actually scratched the running surface of the piston as well. You could see actually in this side it's fine, but here you could see the mark like that. And interestingly, just the heaviest mark just actually coincide with where the pin actually could stretch out and touch the running surface of the cylinder. So this rubber ring is what I meant yesterday. Like I put an intact rubber ring in the first groove and such kind of a pressure release rubber ring in the second groove, so that it will not make a kind of a high pressure during the high pressure gas in between the two sealing rings. But anyway, this piston I will not use it anymore. This is only for demonstration purpose. Let's put it aside and take a look at the connecting rod. So the connecting rod here, it has a sleeve or bush for the piston pin. This piston pin is kind of a high-speed steel material because although I have decreased the compression ratio to 16:1, but under that compression, the pressure force acting on this 22mm bore piston is still roughly 160 kilograms to 175 kilograms of force. That will result in roughly 67 megapascal pressure acting on this piston pane during the compression of the engine. And during the ignition, the pressure on this pane rises up to 80 megapascal. So it needs kind of a the high-speed steel material to withstand that tremendous amount of force. Also, since during the operation, the piston pane, unlike the big end bearing, we will talk about it, unlike this big end bearing, which has a rotation motion, I mean the shaft, the crank web shaft inside has a rotation motion. This end only has a swing motion, like this. So it's much harder to maintain an oil film inside such a swing moving surface. That's another reason we need to use a special material for the small end bearing. And you can see the sleeve for the pane. Oh god, it got under my computer, but yeah. So I have checked these two parts actually still mating very good. Like, yeah, it's actually still very tight fit. So I will keep these two parts as spare parts. So this is a connecting rod, and you could see that the big end bearing has kind of a defection inside the running surface. You see those scratch marks, right? Those marks are not because of the operation of the engine. Because this pair of big end bearing, actually I never run it. It came with another pair of the piston and connecting rod assembly. So upon I received that spare part, I immediately find out the big end bearing has kind of a machine defective like this. So I just keep it aside and never use it because it might ruin the crankshaft. So this is a big end bearing. Doesn't have the oil passage as well, so you need to manually oil it during each operation. But during the operation, I feel it's impossible to oil it because of the centrifugal force of the moving parts. Even if you have some oil droplet contact with this bearing during the operation, the oil will immediately fly away because of its centrifugal force. So before and after each operation, I check the temperature of the big end and I oil them. Yeah, that's just a quick video about the construction of the small diesel engine piston and rod assembly. This piston is made up of aluminium, as I said, and the cylinder liner is also aluminium. Yeah, this is an interesting effect. As I mentioned yesterday in my video about the timing, I mentioned something like the shape of the carbon deposition on the piston top, and today you could actually see that. Please notice that such a condition is after I cleaned the piston. So the residual carbon here is all just hard carbon. I cannot scratch it with a piece of cloth. And here is actually where the piston faces the fuel injector. And this part is very clean. The side of the piston above the top ring has kind of a carbon deposition as well, but anything below the first ring is clean. Yeah, that's all about this video. Thanks for watching.